Dear organizers of the conference, dear participants, my name is David Gajduš. Together with my colleagues from VSL Software Company Košice, Slovakia, and co-authors from Pavel Jozef Šafarik University in Košice, we prepared a solution from the George B. Moody PhysioNet Challenge 2022, which was focused on classifying patients according to the presence of murmurs and overall clinical outcomes based on phonocardiograms. We use data from challenge training set. For each patient, basic demographic data and at least one recording from at least one auscultation location were available. We derive our own Murmur label for individual PCG recordings. Recordings from patients with an identified murmur are divided into two subclasses according to whether the given PCG came from murmur location. Using a supervised contrastive learning and custom loss function, an embedding on the unit hypersphere is found, ensuring that the samples from the same class are placed nearby in the embedding space, while samples from other classes are located much further away. For the second task, we used the clinical outcome labels and used the same approach. As a feature extractor, we have utilized a one-dimensional variant of the popular SNet50 architecture. Using the convolutional layers, we compress the signal to 512 latent factors, apply L2 normalization, and then reduce the space by simple projection head to 16 latent factors, describing the particular PCG. Since the recordings in the dataset have varying length, we create 10 virtual patients from each real patient based on processing evenly distributed 8-second long slices of the original PCG together with signal slice statistics and common patient demographics. This yields 77 explanatory variables for the classification task. Those are used by a random forest classifier to solve both of the challenge tasks. For the Murmur classification, in the first step we separate present patients, and in the second step we take apart the unknown patients. This is done by two random forest classifiers, which were chosen based on the robustness and ease of setting all the hyperparameters. For the outcome classification, we use the same variables and similar approach as for the Murmur classification. However, the feature extracting network was trained on the outcome labels, and we use features in a single random forest classifier solving binary task. By tenfold cross-validation, we have trained separate feature extractors and one or two random forest classifiers based on the challenge task. We provide the final prediction by majority voting of ensemble of 10 models. This is done separately for each of the challenge tasks. Finally, we found that contrastive learning can be successfully applied also in a fully supervised setting, even with small amount of data. Thank you for your attention and feel free to ask any questions.